we've looked at kind of our guidelines or our different techniques that we can use to approach some of these problems. Now, remember, there's not a way that I can show you an example of every single type of problem that you could possibly see with these, because each problem is going to be slightly different. However, if we kind of understand the guidelines or techniques that we can use, those things are going to be very similar from problem to problem. Okay? So we're going to finish up by looking at a couple of our last techniques. Okay? So we have verify the identity. It says tangent of x plus cotangent of x equals secant of x times cosecant of x. So which side do we want to start with? What was our guideline? What did it say? We want to start with the more complicated side. Because remember we said it's usually easier to combine things than it is to break them apart. Yeah? So which one of those sides has something that we could combine or put together? The left side, because we're adding, so usually it's going to be easier to add things than to try and break apart multiplication. Okay? And we're going to look at this problem two different ways. Okay? Because again, remember that just because I do it one way on the board doesn't mean that that's the only right way. Okay? So as long as you show me correct steps, there could possibly be multiple ways to approach the same problem. So what do we want to do first? I have tangent and cotangent. Why? Yeah, this one doesn't have sine and cosine.
Well, it has, the reciprocals.
It does. So the right side has the reciprocals of sine and cosine. So that might be a good indication that I want to convert my tangent and cotangent into sines and cosines. So what is tangent in terms of sine and cosine? Okay. And what is cotangent? So then we have two fractions that are being added together. So how do we combine those? Find a common denominator. What's my common denominator going to be here? Cosine sine. So what do I need to multiply my first fraction by? Sine. So what do I end up with on top? Sine squared. What do I need to multiply my second fraction by? Cosine. So what do we end up with on top there? Cosine squared. And then on bottom, we have cosine sine. So hopefully that looks vaguely familiar. What is sine squared plus cosine squared? Using our Pythagorean identity, it equals 1. So we have 1 divided by cosine of x, sine of x. But what is 1 divided by cosine? Secant. What is 1 divided by sine? Cosecant. Is that what we wanted to end up with? Yeah. Yay. So then we can make our conclusion statement and say, therefore, tangent of x plus cotangent of x equals secant of x times cosecant of x. Now, if we wanted to approach this a different way, is there another way that I could rewrite tangent or cotangent? Probably. There is. Using one of our identities. So what other identity has tangent or cotangent?
Reciprocal.
Reciprocal. So what could we rewrite as what?
Tan as 1 over cosine.
Okay. So again, we have a fraction that we're adding. So what do we have to find? A common denominator. What would my common denominator be? Cotangent. Well, my first one already has a cotangent, so it's just going to stay as 1. But what will my second one become? cotangent squared. Well, what is 1 plus cotangent squared? Have cosecant squared of x divided by cotangent of x. 7. Do you agree? Yeah. So then, again, we're still going to break apart one of our cosecants because we just want one cosecant times cosecant of x divided by cotangent of x. So then how could we rewrite cosecant and cotangent now? Cosecant is going to be 1 over sine. Cotangent is cosine over sine of x. Agreed? How do I simplify a fraction within a fraction?
Keep change left.
Agreed. So I'm going to keep my 1 over sine of x. Then I'm going to flip to get sine of x over cosine of x. Well, what happens to my sines of x? They reduce. So then we just have 1 over cosine, but what is 1 over cosine? Secant. So again, do we end up with what we wanted? Yeah. So that would be a valid way as well. Now, this way was a little bit longer, okay, but none of these steps were like super complicated or super hard. So sometimes even if I have to do a few more steps, like that would still take less time than trying to sit here and stare at it for 5 minutes to figure out what to do. Does that make sense? So that's why I said, like, just try something. Even if that's not like the fastest way, it's still faster than spending like 10 minutes just staring at a blank piece of paper. Does that make sense? Because especially on our test next week, where we only have like 45-ish minutes to do all of the problems, okay, you're not going to have time to just stare at a blank piece of paper and figure out what to do. You're going to need to do something. Does that make sense? Okay. So let's look at another example. What do we have here? Secant of y plus tangent of y equals cosine of y divided by 1 minus sine of y. So what do we want to do first? Or which side do we want to work with first? Which one?
Left.
Yeah, I would work with the left side because again, we have addition and it's going to be easier to combine addition some way than it is going to be to try and break stuff apart for right now. So, if I start with secant of y plus tangent of y, again, if I look at the right side, that's what we want to end up with. What does it have in it? Cosine and sine. So what might it be helpful for us to convert things to? Cosine and sine. So what is secant in terms of cosine or sine? 1 over cosine. And what is tangent? Sine over cosine. So I have two fractions. But what's nice?
Denominator.
They already have the same denominator. So we end up with 1 plus sine of y divided by cosine of y. So, can I use my Pythagorean? I didn't agree on this. No, because is my sine squared? No. Okay. Do I have anything that reduces? Not really, because if I were to like separate this out, we would get back to what we started with, right? So, remember that we said we are not allowed to work with both sides at the same time, right? Like I can't add 1 to both sides or subtract 1 from both sides. However, sometimes it is helpful for us to work with one side and get to a stopping spot, and then work with our other side and try and get to that same place. Because just like if I have, say, like A equals B and B equals C, then what do I know has to be true? A has to equal C. So if I can show that my left side equals something and the right side equals the same thing, we didn't technically show that they equal each other, but because they equal the same thing, they have to equal each other. Does that make sense? Yes? So for this one, what would I do? We've looked at one kind of like this before. So going down our list of guidelines, what did we have? Write things as sines and cosines, yeah? Is it already in sines and cosines? Yes. Okay. What were your other ones? Should have them written down in our notes. What were our other guidelines? We have
Pythagorean identities.
Pythagorean identities. I don't have anything that's squared, so I can't use that one. What else?
Multiply
Factor.
by 1.
Can't factor, but I can multiply by a strategic one. Now this is what we want to do here. So what do I want to multiply by? Not just, it's going to have a sign in it, but not just sign over sign. 1 plus sign. Do we remember what that's called?
Inverse.
Not the inverse. What's it called when I just flip the middle one? It does start with the C. It's the conjugate. So remember that we have those when we have radicals, and we have those when we have imaginary numbers. When we flip that middle sign, it allows us to be able to reduce things in the bottom, because now when I multiply those together, what do I get in the bottom? Which means that they're going to multiply to 1 minus sine squared of y. Which is why we picked the conjugate, because that middle term goes away. So what is 1 minus sine squared? Cosine squared. Well, we have a cosine on top and a cosine squared on bottom, so what happens to those? One of them is going to reduce. So we end up with 1 plus sine of y divided by cosine of y. Does that equal the left side? It equals secant plus tangent? No, but it equals what we got our left side to equal. So because we showed that they are the same thing, we can then say that secant of y plus tangent of y equals cosine of y divided by 1 minus sine. So in this case, it's even more important that we do a conclusion statement, because technically we didn't show that the left side equals the right side. We showed that they equal the same thing, so we do need to state, well, because of that, they also have to equal each other. Yes? Questions on any of our steps there? Okay, we have 2 more examples now. So those are signs. They just didn't copy right. So what side do we want to start with here? Probably the left side. And what do we want to do in order to simplify? I probably wouldn't put it in cosine yet. What else do we know about it? There's a squared. And what can we use when we have a squared? Pythagorean identity. So what is cotangent squared? Cosecant squared of theta minus 1, which is a what? secant being squared. 1 is a perfect square. So it's a difference of squares. So what can we do with it? Factor it. What does it factor to? Cosecant of theta plus 1. And then cosecant of theta minus 1. Well, I have a 1 plus cosecant of theta. Is that the same thing as cosecant of theta plus 1? Yeah, it's addition, so we can write it in either order. So what do we end up with? Cosecant of theta minus 1. So then, from here, we have two options. Either we can rewrite cosecant as 1 over sine, find a common denominator, and combine them, which would be one way. Or I can also notice that over on the right-hand side, I just have one thing in our denominator, right? So am I allowed to break this into two fractions? Yeah. What is 1 over sine? Cosecant, and sine divided by sine is 1. Do they equal the same thing? Yeah, so we can say, therefore, cotangent squared of theta divided by 1 plus cosecant of theta equals 1 minus sine of theta divided by sine of theta. Yeah? We're okay with that? Questions on any of our steps that we did for that one? So what's the last technique that I had on our guidelines list that we haven't talked about yet? Yeah. So we're gonna do a little math magic. Yay. So let's look at A first. Tangent to the 4th of x equals tangent squared of x times secant squared of x minus tangent squared of x. So, which side do I probably want to start with? The right side, yeah. So the way that a rabbit works, which is just what one of the other pre-calc teachers calls it, which kind of like it, is I want to look at what I want to end up with, which in this case is tangent to the 4th. Agreed? Yeah. And what we want to do is factor out the rabbit, which is basically what we want to end up with. So if I want to end up with tangent to the 4th, I want to factor out as many tangents as I can with what I have. You with me? Yeah. So how many tangents can we factor out? 2. So what are we left with?
Secant squared of x minus 1.
And what is secant squared of x minus 1? Tangent squared of x. And what is tangent squared times tangent squared? Tangent to the 4th. So that would be our answer. So on part B, if we start with the right side, so how many cotangents can we factor out?
1.
Just 1 in this case. And what are we left with?
1 plus cotangent squared.
Well, what is 1 plus cotangent squared? Cosecant squared. And what is cosecant squared x times cosecant squared x? Cosecant to the 4th times cotangent of x. Any questions on either one of those?
Do you always have to write the therefore statement?
It's very much preferable, yes. Because it tells your reader that you know what you were trying to prove. Other questions?